4.2 Determinant of Matrices. Determinant A is simply by writing A using vertical lines in place of square brackets. Determinant for a 2 by 2 matrix. The determinant for 2 by 2 matrix is obtained by subtracting the products of the elements along the diagonals. So determinant A is equal to A times D minus B times C. Example 9. Given A 2538 and B 3252, find determinant A and determinant B. Determinant A is equal to determinant 2538, and this is equals to 2 times 8 is 16 minus 5 times 3, 15, so determinant A is equal to 1. Determinant B. Determinant B is equal to determinant 3252, and this is equal to 3 times 2, 6, minus 2 times 5, 10. So 6 minus 10 is equal to negative. Determinant for a 3 by 3 matrix. Before defining the determinant of 3 by 3 matrix, we need to find the minor and cofactor of a square matrix. Minor Mij. Mij is the determinant of a matrix obtained by deleting the ith row and jth column from A. For the matrix A 1 2 1 3 4 2 1 4 3, find M11 and M23. So M11 is equal to determinant. Okay, M11 means we delete the first row and the first column. So M11 can be obtained by deleting the first row and the first column, then find the determinant of the resulting 2 by 2 square matrix. So we find the determinant 4, 2, 4, 3. And here 4 times 3 is 12 minus 2 times 4 is 8. So M11 is equal to 4. And then find M23. M23 means we delete the second row and the third column. So we find the determinant of the resulting 2 by 2 square matrix. So determinant of 1, 2, 1, 4. So this is equal to 1 times 4 is 4 minus 2 times 1 is 2. So M23 is equal to 2. If A is a square matrix, then the cofactor Cij of the element Aij is given by Cij equals to negative 1 to the power of I plus j times Mij. The cofactor of an element is the minor of that element multiplied by 1 if 1 plus j is even, or negative 1 if I plus j is odd. Okay, now let's do matrix A. A 1 2 1 3 4 2 1 4 3. Find C11 and C32. C11 by using the formula of cofactor Cij is equal to negative 1 to the power of 1 plus 1 times M11. So here we will get an even number 2. So negative 1 to the power of 2 is 1. And then here M11 means by deleting the first row and the first column, so we can multiply by determinant of 4, 2, 4, 3. So this is equal to 4 times 3 is 12 minus 2 times 4 is 8, and the answer is 4. Okay, now let's do example. The next example, C32. C32 is equal to negative 1 to the power of 3 plus 2. So it will give us an odd number, 5. So negative 1 to the power of 5 is equal to negative 1. And then 3, 2 here means we delete the third row and the second column. So we need to multiply by determinant of 1, 1, 3, 2. So here we can calculate that negative 1 times 2 minus 3. So here the answer is equal to positive 1. Okay, example 10. Given P matrix 7, 1, 2, 1, negative 1, 3, 5, 0, 1. Find the cofactor matrix for P. So for this example, you can do on your own. But to find the cofactor matrix, you need to find C11, C12, C13, C21, C22, C23, C31, C32, and the last one is 3, 3. Okay, so this is the answer for cofactor P. Determinant for a 3 by 3 matrix. Determinant for a 3 by 3 matrix can be obtained by cofactor expansion about any row or any column. Instead of calculating negative 1 to the power of I plus j for each cofactor, the following sign convention can be used to find determinant of 3 by 3 matrix. Notice that the upper left position is a positive. Then the signs alternate: positive, negative, positive, negative, positive, negative, and so on. For this matrix A, we expand along the first row. The signs in the first row are positive, negative, and positive, so that the determinant A is equal to A11 times C11 plus A12 times C12 plus A13 times C13. So this is equal to A11 here means the element in the position in the first row and the first column, that is A. And then C11 here, find the cofactor of the element in the position in the first row and the first column. So we delete the first row and the first column so that we can define the determinant of E, F, H, I. Okay, next. A12. A12 is the element of P. So B here we have the signage negative. So that's why we put negative 1 here. And C12 means we delete the first row and the second column, so that we will get the determinant of D, F, G, I. Okay, then for A13. A13 means the element for C. And the signage here is positive, so now we can use positive C. And C13 means we delete the first row and the third column. So you can find the determinant of D, E, G, H. Expanding about any row or any column gives the same value of determinant A. However, the computation is easier if the selected row or column contains the most number of zeros. Now, let's do example 11. Find determinant A for matrix A 3, 2, 3, 0, 1, 2, 1, 4, 5. Since the first column contains a 0. So we expand the cofactor about the first column. So the determinant A is equal to, the signs in the first column are positive, negative, and positive. So this is equal to, okay, this is the element, by using the formula A11 C11. So the element is 3 for A11 times C11. C11 means we delete the first row and the first column. So the determinant is 1, 2, 4, 3. Okay, and then the next element is 0. So minus 0. 0 multiplied by any value becomes 0, and then plus 1. So plus the element is 1 times, okay, now we delete the the third row and the first column. So determinant of 2, 3, 1, 2. Okay, now we can calculate. So 3 times 1 times 5 is 5. 2 times 4 is 8. So 5 minus 8 minus 0, 0. Plus 1. So 2 times 2 is 4 minus 3 times 1 is 3. So the answer is negative 8. We also can expand the second row and it will give the same value of determinant A. So you can try on your own by using the second row. Example 13. Given P is a matrix 2m, -1, 6, 1, 9, 3, m, 1, 2m, where m is an integer, and given that determinant P is equal to 28. Find the value of m. Since we are given the value of determinant here, so we can find the determinant of P by using the first, let's say we choose the first row. So determinant P is equal to 2m times the determinant 9, 3, 1, 2m plus 1, 3, m, 2m plus 6 times determinant of 1, 9, m1, and given that determinant is equal to 28, so we can equating to 28. Okay, now we can simplify this expression. So 2m times 18 minus 3 plus 2m minus 3m plus 6 times 1 minus 9m equals to 28. So we simplify this equation. We will get a quadratic equation that is 36m squared minus 61m minus 22 is equal to 0. And then in order to find the values of m, we need to factorize. So we will get m minus 2 times 36m plus 11, and this is equal to 0. So the values of m are, m is equal to 2, m is equal to negative 11 over 36. But it states that in the question m is an integer. So negative 11 over 36 is not an integer, so we must state that this is rejected. And the last answer is m is equal to 2. Hence, find the cofactor matrix of P. Okay, so you can do on your own by finding C11 until C33. So this is the given answer. Properties of determinant A. Determinant A is equal to determinant A transpose. For example, 2, 3, 4, 5. the determinant is equal to determinant 2, 4, 3, 5. This is A and this is A transpose. B. If every element in a row or column is 0, then determinant A is equal to 0. All elements in the second row are zeros, so that determinant A is equal to 0. C. If two rows or columns are interchanged, the new determinant is negative of the original. The first example here is showing the interchanging the first row with the second row, so that the new determinant is negative from the original. For the next example, the first column is changed to the second column. D. The corresponding elements are equal in two rows or columns, then determinant A is equal to 0. For example, matrix A, the first and the second rows are identical, 2, 3 and 2, 3. So determinant A is equal to 0. E. If a square matrix is multiplied by a scalar, then the determinant of the new matrix is K times the determinant of A. For example, 3 times determinant A, B, C, D. We can take out the factor 3 for this determinant, so that 3 times 3A, B, C, 3C, D. Multiply 3 is the first column or first row. F. If determinant A times determinant B, then this is equal to determinant A, B. Example 14. Given A matrix 2, 4, 0, 1, negative 3, 1, 5, 2, 0, B matrix 2, 4, 0, 3, negative 9, 3, 5, 2, 0, and C matrix 10, 4, 0, 5, negative 3, 1, 25, 2, 0. Show that determinant A is equal to 16. So let's do together. A. Determinant A is determinant 2, 4, 0, 1, negative 3, 1, 5, 2, 0. By using the third column, okay, and then the signage is positive, negative, and positive. We expand the third column so that the determinant A is equal to 0 minus determinant 2, 4, 5, 2 plus 0. And we will get the answer is 16. B. By using the result in A, find the values of determinant B and determinant C. From the sentence, by using the result in A. So just now we got determinant A is equal to 16. So 3 determinant B is equal to determinant 2, 4, 0, 3, negative 9, 3, 5, 2, 0. 3 is the common factor for the elements in the second row. Therefore, we take out the common factor 3 from the determinant. So 3 times 2, 4, 0. So the second row becomes 1, negative 3, 1, 5, 2, 0. And this is the value of determinant A. So from A, we got just now is 16. So that this is equal to 3 times 16. So the answer is 48. Okay, for determinant C. Determinant C is determinant of 10, 4, 0, 5, negative 3, 1, 25, 2, 0. Look at the first column. 5 is the common factor for elements in the first column. So we can take out 5 times determinant. The first column becomes 5, 1, sorry, not 5, but 2, 2, 1, 5, and the rest are same, 4, 0, negative 3, 1, 2, 0. And this is also determinant A. The answer is 16. So this is equal to 5 times 16, and the answer is 80.